Hi, I'm Eddie Raditic, and I've chosen to talk about Russel Ohl and the invention of the solar panel as my influential discovery, influential person. So, over the 4.5 billion year lifespan of the Earth, it has changed drastically. It's been a planet of water, then we had Pangea, and it's evolved into what it is today. Now, the Earth produces a finite number of fossil fuels, or produced a finite number of fossil fuels, and we have used those fuels to power our technological advances and power our society to date. They power our cars, they power our buildings, they power everything. Now, eventually we will run out of these fossil fuels and we'll have to find a alternative source of energy, and the two best sources of energy are kind of right here in this picture. We got sun, we got water. So I've decided to focus on water because I think that, or on sun, because I think that is the future of clean and reusable energy. And in able to do that, we have to understand where the solar panel came from. Now, Russel Ohl, he is not the sole producer and inventor of the solar panel, but he discovered the technology and the science behind the solar panel. He was born in Allentown, Pennsylvania in 1898, and he was quite remarkable as a student. He got through high school and started university at Penn State University at the age of 16. He studied science all the way through, and then about halfway through his junior year, it was during the World War, he heard his first radio transmission. Now this greatly enthused him. Became his fascination. And because of this, he took a class on tube mechanics and vacuum tubes during his senior year and focused all of his energies after graduation on understanding radio waves and how they work. Because of this, he worked at Westinghouse and then at AT&T before finally settling in at Bell Labs. At Bell Labs, he continued to research radio waves, and through this research, he became fascinated with superconductors, and specifically crystalline superconductors and how they may or may not be able to one day lengthen the wavelength of a radio wave and strengthen it, thus improving radio signal and communication possibilities. This was his dream. Now, about 1950, he discovered that the crystalline structure of silicon has a P-N ratio, which means positive-negative ratio, that creates a barrier. And this barrier, when light hits it, creates spontaneous electric current. And he thought that was interesting, but it wasn't necessarily conducive to his main goal of using superconductors to lengthen radio waves. So he stopped kind of looking into it. So there was a couple of scientists that picked this up. It was Darrell Chaplin, Calvin Fuller, and Gerald Pearson. They took the discovery he made and started making silicone solar panels and creating energy out of creating electricity out of solar energy. These were first mass-produced by the Bell Labs in 1954. To date, they haven't really had that much use, but they have tons of upside, unfathomable upside even. So in order to understand why they have upside, we have to understand what's going on currently. Currently, fossil fuels are used, and the burning of fossil fuels emits CO2. CO2 not only pollutes water, but it pollutes the Earth's atmosphere. Now, because the Earth's atmosphere is being polluted, the atmosphere is deteriorating. This has caused the vast climate change over the past 50 years. It's causing the polar ice caps to melt, and it's raising sea level, thus putting more land mass underwater. those are the physical things we can see. Now, when you look at the things we can't see, more people are getting cancer, sun cancer specifically, and we're being exposed to more harmful UV rays than ever before. So, those are a couple of things that will be changed by using solar energy. Now, it's not to say that solar energy doesn't have its downside. Solar energy, in order to create enough solar energy for it to be sustainable, we'd have to create plants, and not only plants, but the solar panels necessary for those plants to create electricity and then store the electricity. The big downfall with this is you have to find enough land to do it, and you have to find enough land that's usable over a certain period of time, a long term, that will not be susceptible to degradation and habitat destruction. So that's the big downfall. However, you could use a desert or dry climate areas that have maximum sunlight, as well as little to no habitat or forestry, and that would create the maximum output without harming the Earth's environment. In addition to that, there's a little bit of a water usage problem. The plants used to create electricity out of solar energy are thermoelectric plants, and so what they do is they take the heat generated by the spontaneous current and turn it into electricity. Obviously, thermoelectric, heat and electricity, so heat is a byproduct of the electricity created. Now, in order to be able to run a plant for a significant amount of time to create a significant amount of electricity, you have to be able to deal with the heat being produced by the electricity. In order to do this, a lot of plants use water as a cooling agent. A, because it doesn't introduce any harmful chemicals to the environment, and B, because it has natural cooling properties. 600 to about 650 gallons are used for every 1 megawatt of hour produced of electricity, so it's a lot of water used to cool it down. However, new advances in thermodynamics have allowed for a dry and wet cooling process, so you could almost half the amount of water being used. So further advancements in this could kind of eliminate the water problem. So there's a little bit about Russel Ohl and how he discovered the PN barrier in crystalline silicone, and how that in turn has been used to make solar energy out of solar panels. So, I think this is one of the most influential things that has been made, because not the ramifications it immediately had, but the ramifications and what it could be used for in the future to create energy without polluting our planet. So, thank you.